Good evening.
Yeah.
Good evening, sir.
Yeah. Coming to the
Good evening.
point, today's session is solar manufacturing process. That is our topic actually. Before going to the topic, let me introduce myself. Myself is Ramu from Credence Solar Panels Private Limited, which is located in Rajkot. Okay. Uh, so I'm looking operations department overall of the company, and I have around 12 years experience in manufacturing process. From 2008, I have started my career in solar only after my graduation, and now I am associated with the Credence Solar Panels Private Limited. Okay, so coming to the solar manufacturing process, before going to the manufacturing process, I will explain the basic things of solar, mainly related to solar PV. So coming to the sun, from solar or sun, we are getting two energies. One is heat energy, second one is photon energy. These two energies mainly coming from sun. So heat energy is used for solar water heating systems and solar cookers. That is a thermal related applications. And coming to the photon energy, it is coming to the electronics related, means solar PV modules coming to in the photon energy subject. That is what photovoltaic modules, PV modules. So this is example of heat energy, water heaters and cookers. This is a basic operation of a heater, which is it is not related to our subject, so I can skip this. So coming to the photon energy, mainly the sun, from sun, one photon energy will come, and it will, main topic is, this is the main application. The solar cell is a combination of p-n junction. So whenever that free electrons are there in the material, if the photon hits this junction, then it will eject free electrons to the outer side. So we can collect these electrons with some potential, and we can connect it to the load. So that is why this is a photovoltaic. Voltaic means it is not storage. It will generate instant energy. We have to collect it and we have to save it in the batteries, in the form of batteries or heat, anything you can, or utilize it at the time of same time. So that is why it is called voltaic, photovoltaic modules, solar PV modules. So coming to the generally, if you see the solar cells, basically this is a ingot, which is two types of solar cells. Mainly the panels are cells. There are two type of technologies. One is mono, and another is multi. Monocrystalline or multicrystalline. You can call it as a polysilicon, polycrystalline. Somebody calling multicrystalline. It is a poly module, which is related to this one. Present in India domestic market, DCR market, major contribution is related to polysilicon, poly wafers, means indirectly multicrystalline, which are importing from many higher watt peak modules, coming to the mono and mono PERC technology, which is this type of process. The ingots is manufacturing like the cylindrical shape. Okay, I think it is audible, right? Hello.
Yes, sir. Yes, sir. Very,
Yes,
very
sir. You
much.
are audible.
Yeah. Means I think I'm not so fast, and if any doubts, you can ask me immediately. There's no issue. Okay. Yeah. So coming to this is a mono silicon wafer, and it is a mono cell. Actually, by verification, physical verification, you can identify with this pseudo shape in earlier, because it is manufacturing with a cylindrical shape and cut into the specific size. So that is why corner chamfers will be coming in the monocrystalline cells, major cells. Coming to the latest technologies, it is the coming to the sizes of the solar cells. Earlier, it will be the coming to that, I want to explain earlier. The solar cells, the generation of solar cells is from last 20 years. Earlier days, it is a only 100 by 100 mm size, means 4 inch by 4 inch. that is the size of the cell. See, if the size is like this, one cell, it is 4 inch by 4 inch. So if the area increases, then current will increases. So the power will increase. So accordingly, the manufacturers, means cell manufacturers, are developed bigger sizes of cells. From 100 mm by 100 mm, it will increase to 125 by 125 mm, 5 inch. Later on 6 inch. Uh, Nowadays, it is coming to 166 mm, 182 mm, and 210 mm. This is the sizes of the cells, the square size. So maximum highest size means from 166, it will be coming to the monoperc only, not in poly. Polycrystalline is limited to up to 340 or 350 watt peak only, and the size is limited to 158.75 by 158.75. That is a poly technology. For mono technology, it starts from 158 and it is end with 210 mm. The size. So that is why, means if you take the watt peak in the consideration of watt peak, monocrystalline will give 400 watt peak in 158 size, and around 450 watt peak of the module in 182, sorry 166, and 500 550 in 182 mm, and above 600 and 670 in 210 mm modules. So the cell is increasing the size, it will increase the module size, it will increase the power of the module. So indirectly, if you can, the BOS project cost will reduce due to this. So coming to the manufacturing process, see, this is the background of the solar cells and solar cell technology. Because while going to the manufacturing process, we can understand that what is solar cell and what is wafer and like this. This is a wafer, this is a cell, this is ingot, this is called bus bar. So nowadays it is coming up to 12 bus bar. So to reduce the resistance and increase the efficiency, and this is the cell technology. So my now topic is solar PV manufacturing process. So coming to the manufacturing process, mainly the list of raw materials. What are the BOM? Actually, solar PV manufacturing is assembly process, not a manufacturing process. First of all, because we can brought the materials, all raw materials from outside, and we have to assembly with as per customer requirement, and provided with the 25 years warranty, which is a industry standard warranty. So coming to the raw materials, the major items are, you can note it down, and I will share this PPT to CBIP. They will issue to them. And these are major items. Key is solar cells. And second one is glass, copper, flux, EVA. EVA means ethylene vinyl acetate. This is a hot melt adhesive to use to laminate the solar cells. And backsheet, frame, junction box, RTV, foam tape, and marking labels, whatever required. These are the key items and list of raw materials, major raw materials for to make a module, solar PV module. So coming to the layer, this is the cross sectional. From the top, it will be glass. EVA, which is I told EVA encapsulant. It is a hot melt adhesive, and this is a crystalline cells. Again EVA, then backsheet. It will be coming to the frame and junction box. This is the cross section of the solar PV module. So the manufacturing, how it will be done. This is the process flow chart of solar PV manufacturing. So nowadays, many manufacturing processor will in automation only, not a manual. So I can explain both the things, how the manual process is going on and how the automation is changing over to automation from manual process. So this is the basic process flow chart. I can explain each stage later on. Coming to the process, auto tabbing stringing, and it means we can assemble the cells in a such a way in series connection to make a module. Later on, visual inspection. If any problem in the process, then it will be going to the rework stage. Later on, busing means we can connect all the solar cells together with this bus bar. That stage is called busing. Then we can quality stage of hotspot test. It means is there any thermally problematic cells we can observe in this stage. If it is there any problem, then we have to remove that particular cell and we have to replace with a good cell. And then layup. Layup means once the solar cells are process done, we need to keep the glass, EVA, solar cells, again EVA and backsheet. It is called layup process. Then we can see that electrical inspection with a halogen lamps to check that voltage and currents they are coming or not. It is series connection. Any breakage is there in a continuous section. We can observe that it is okay. Then it go to the EL test. EL means it's like a electroluminescence test, which gives that any current mismatches and any cracks, micro cracks, it will observe from EL test. Then again visual inspection, going to the lamination. In lamination, it will be become a single layer with after lamination, we can trim the excess materials of edge materials. Then framing will do and cleaning, junction box testing and final testing, again EL testing and packing. This is the sequence of production process. So we will go to the each stage. Earlier days means nowadays also few companies are manufacturing like this. This is the solar cell. We need to join with the copper with soldering iron. This is called tabbing. We need to tab the lead on the solar cell. This is called tabbing process. Like this. In solar cell, the blue color is showing that it is a negative terminal and below this is positive terminal. We need to join positive, negative like that in a series connection. So after this is the tabbed cells. Again, we need to join with each other in a series connection. Here you can observe hope it is visible. See, this is the positive side and the blue color is negative side. So the copper is coming from the blue sides to gray side, and this blue side to this gray side, and this blue side to this gray side. So like this, it is a series connection. Understand? I think. Hello.
Yes.
Okay. So this is called stringing process. So nowadays the automation is coming, auto typing stringing. So both process will come here itself. We need to load the cells and copper. So there is a automatic IR lamp technology is there, induction technology is there. Many technologies are there for soldering. So the cells will come here, top and bottom of the copper in the same time. It will solder here. So this is automatic tabbing stringing process. I will show the video also later on for understanding. And again, inspection of strings. While doing this process, this is the problems we can get from the machineries. The improper soldering, and there is a cracks are there. So before laminating, after lamination, we can't do anything. The model will be separated as a grade wise. So before that only we need to thoroughly check there is no even single problem is going to the lamination side. So we have to check this in different stages. One is inspection of string level, So if there any cracks are there, we have to desolder this one and again with good cell resolder. And this is the cell problems. The screen printing any issue is there a thing. This is come from visual inspection. By visually you can check it. And this is the lead process. And this is the busing. So once these lines are done, we need to connect each other with these lines. So this is called busing process. It is bus bar. We need to connect it with this solar cells. Here we can get that output leads.